Okay, we're going to look at some models for percent. And to begin with, I want to point out that percent, if you split this word up, per cent is short for centum, which means 100 in Latin. So there are 100 years in a century. A centurion is over 100 soldiers, and so forth. So percent means out of 100 or per 100. So if I'm looking at 56%, I'm looking at 56 per 100. The fraction bar in a fraction, when you're talking about rates, is always read as per, like miles per gallon, pays in dollars per hour, things like that. So the bottom of the fraction, my whole part is 100, and then the shaded part, if I were to look at this, would be 56 out of 100. So percent is a part to whole ratio where the whole is 100. Okay, and in fact, if you look at this sign right here, so we have some number, 50 out of 100. But if you look at this sign, it's a shortened form of representing a fraction. Not zeros, but some. We can model percents in a linear fashion or like an area model, just like we do with multiples, whole numbers, fractions, and so forth. So suppose I had a number line here, and this is 0, and this is 1. I know when I divide this up into 10 pieces, each piece is a tenth. So counting along the number line, I would have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then this would be a whole. My decimals are a little light here, so let me darken those up. Okay. Let's also write what we know if this were a fraction bar that's divided into tenths. Here I'd be at 0. Here I'd be at 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. So we've already learned to represent decimals as fractions and vice versa. So now, what we know about equivalent fractions is that if I were to write these fractions with a denominator of 100, I would multiply the top and the bottom by 10. So this would be 0. This would be 10 over 100, 20 over 100, 30 over 100, 40 over 100, 50 over 100, 60 over 100, and we continue till we get to 100 out of 100. Now, what we know about percents is that the percent is the part out of 100. Well, this is 0 parts out of 100. This would be 10 parts out of 100, so percent. 20 parts out of 100, percent. 30 parts out of 100. 40, 50, and all these are percents. 60%, 70%, 80%, 90%, and 100%. So let's look at some percent problems. I've got 4 written up here, but we're going to do one at a time. So we're going to look at number 1 here. What is 15% of 7,100? So if I marked this all the way to 7,100, okay, and each of these are still 10%, 15% would be about right here. Okay, so I know the percent. I don't know what this number is equal to, but I know that this is also 100%. So I can set up a proportion. And I can use the percents, or I can use an equation, but I'm going to use the percents. So x out of 15% is the same thing as 7,100 out of 100%. So we'll solve that, multiply. We can cross multiply. Technically we're multiplying both sides by 100 and then both sides by 15. So if I take 100x is equal to 7,100 times 15. 7,100 times 15 would be 106,500. And now I can just divide both sides by 100. So that number would be 1065. 1065. So I'm setting up a proportion between the numbers I'm given and the percents I'm given. Now, if you wanted to check this answer, you could take 1065 and divide it by 7,100. And you get 0.15. And we know that 0.15 is the same thing as 15 out of 100. We would read this 15 100ths, 15 out of 100, or 15%. So if I want to look at number 2 here, on the top I'm going to model the numbers, values, and on the bottom I'm going to do the percents. So I'm going to go from 0 up to 420. 420, I'm not writing very well today. And I want to know what percent out of 100 would 21 be. Now if I were to divide this up in half, I would say it's probably around right here. If I divide it in half and then kind of gave an estimate, I'd say it's somewhere around in here. So that's where 21 would be out of 420. What I don't know is what percent out of 100 am I looking at? So if I set this up again as a proportion, 21 out of 420 is the same thing as x out of 100. Cross multiply, I get 420x is equal to 2100. And now when I divide both sides by 420, turns out that x is 5. So 5%. 21 is 5% of 420. Now before we go on to 3 and 4, I want to look at the algebraic approach to solving these problems. And what we need to remember is that in a word problem dealing with fractions, decimals, or percent, the word of means to multiply. The other thing is that we do not use the percent to calculate. We need to convert percents to decimal before calculating. So number 1 here, I want to know what is, I don't know what the number is, 15% of 7,100. So x is equal to, change this to a decimal, make the of multiplication, and when we multiply these together, we get 1065. Number 2, if I write this as an equation, 21 is what percent of 420? So 21 is, of means multiply, 420 times x. Now whatever we get, we'll have to convert back to a percentage because we get a decimal when we calculate. So we'll divide both sides by 420. And we get that x is equal to 0.5. As a percent, then we find out that it's 5%. So now let's look at the third and fourth problem, but this time we'll approach it with the algebraic equation. So we have 6,300 is 210% of what? I'll call the what x. So let me write this. Now, 210%, I move the decimal back, and I get 2.10 of is times x. Now I'll multiply both sides, or divide both sides, excuse me, by 2.10. And I get x is equal to 3,000. Now let's make this, see if this makes sense. 210% means you get as much back, another one back after that, and 10% more. So it's 100% plus another 100% plus 10%. So if I take 300 or 3,000. Add on another 3,000. And then take 10% of that, which is 300. I get 6,300. So it does check. Makes sense. So that was 3, 4. 315 is what percent of 52,500? Okay, now when I get this, I'll have to change my answer back to a percent because calculation gives me a decimal. So 315 equals 52,500 times x. Divide both sides by 52,500. And we get x is equal to 0.006. Now as a percent, we move that over and that's 0.6%. Now if we look at 315 compared to 52,500, it's very, very small. So the percentage will be very, very small. Now let's look at a word problem. And we're going to use the model here to do this instead of just setting it up. Okay, so with algebra, the desktop computer sells for $1,800 to the general public. If you purchase one through the university, the price is reduced by 20%. What is the sale price? Okay, now if the price is reduced by 20%, then the sale price is what percent? It's only 80% of the original price. So, if I have my price going up to $1,800, what I want to know is, here's where 80% is. I want to know what is that sale price. So the sale price out of the $1,800 is the same thing as 80% out of 100%. So I can set this up I can then reduce my fraction just to make things a little bit easier for me. I'm not reducing it all the way because dividing by tens is really easy. So 1,800 times 8 is 14,400. Now if I divide both sides by 10, I get that x is $1,440. And on these you want to make sure that your answer does make sense. So you're getting a discount, so your price should be lower than the original price. And it is. Now it shouldn't be a whole lot lower, but it should be somewhat lower. You can solve this using an equation too. The equation would look like 80% of 1,800 is equal to what? Now, that's a shortened form of this equation. Sometimes in algebra, you look at it this way. I'm going to pay 1,800, okay, and then I'm going to subtract off, or I'm not going to pay that. I'm going to subtract off 20% of 1800 to get the final amount. And you'll find out that these are the exact same calculations. But you are free to use a model. Okay, the enrollment at Eastern High School is 1,150. If the daily attendance is 96%, how many students were absent each day? Okay, so we've got a couple of ways we can do this. If I set this up as, I'm looking at 150 or 1,150 students. Okay, now if I look at 96%, which would be about right here, because there's 100%. 96% is how many people are there. But the question asks me how many students were absent. So I could do this a couple of ways. I could first find out how many were there, which is going to be represented by X. So X out of 1,150 is equal to 96 out of 100. Cross multiply. 96 times 1150 is 110,400. Now divide by 100. And so X would be, in this case, 1,104 students. But keep in mind, this is present. Now, if that many were present, and there should have been 1,150 there, then how many were absent? Well, if I take, so I found out this is 104. So the number absent we would find by just subtracting those two. Which turns out to be 46. So 46 students were absent. Now, if I had set up a proportion for the percent who were absent, if I know 96% are present, how many are absent? Are absent. Well, that would be 4%, right? So I could set it up as X out of 1150 is the same thing as 4 out of 100. And this will give me the percent, the number absent without having to subtract. So I get 100x is equal to 4,600 or 4,600. Divide both sides by 100 and I get x is equal to 46. So it depends on which percent you want to look at, and that will depend on the problem you're giving. So are we looking at percent present but want to find percent absent, or are we looking at percent absent and that's what we want to find? Okay, finally, converting between decimals, percents, and fractions. Now, if you watched the basic skills test video, I talked about this. If I have a fraction and I want to change that to a decimal, there's several ways of doing this, but not necessarily the easiest way in this case. But if I had something that was didn't have a denominator of 5 or something that I could multiply by to get 100, I would just remember that a fraction bar means division. And 3 divided by 5 is 0.6. Now that I have a decimal, I could just change the decimal to the percent. So this would be how many out of 100? It'd be 6 out of 10 or 60 out of 100. But what's 60 out of 100? 60%. And then if I want to go back to a fraction, $60 out of 100 would reduce to 6/10, which would reduce to 3/5. So all of these are just ways to talk about rational numbers. Percent itself is not a number, but when you write it as a fraction, it is the number. So you can convert between any one of these to any other. If you have 0.37, if you want to write that as a fraction, you would read this 37/100ths. So you would write it 37/100ths. And then 37 out of 100 is 37%. Another way to do that, to change to a percent, you always multiply the decimal by 100 and add the percent sign. If you want to change a percent to a decimal, you find out where the decimal would be in the whole number. Then you're going to move the decimal back 2 places, so you're going to get 0.45 and drop the percent sign. But it all comes from knowing these definitions and how to convert between these. Now, one thing we've been talking about with all these rational numbers is numbers that I can actually write a terminating or repeating decimal. So just a look into the other numbers. If I considered something like if I considered something like radical 2 or pi, okay, we learned that rational numbers can always be expressed as terminating or repeating decimals. Oops, repeating decimal numbers. So 1/10, 0.1. It terminates. It doesn't go anywhere past the 0.1. 3/7. If you do 3 divided by 7, you're going to come up with 0.4285 71.42, and this thing will be repeating over and over again. So you come to a place where you have a series of numbers or a single number repeated. But what about radical 2 and pi? And there's other numbers like these. These cannot be expressed as terminating or repeating numbers. These type of numbers are called irrational. And I have posted a video. It's a YouTube video that I put a link to in your video section that I'd like for you to watch. I think the instructor does a really good job of explaining some concepts about irrational numbers.